Hello, this one will be really short. I'm just finishing page 3 and 4. Page 3 and 4, the table. Watch the second video for the examples. And the first video for the first 2 pages. I also did post the filled out notes on Canvas for you, okay? But let's just summarize. I think we did all these. Just kind of talking about finding relative maximum and minimum values. Those are the graphs where we have these peaks and valleys. And take a look, we have one right here, one lowest point, this corner right here, and then that point right there. These 3 points are called relative minima. And we have the other types. The highest point of these areas, these are called relative maxima, and we can find them by first finding the critical values, right? So remember, critical values are either when the derivative is equal to 0 or where the derivative does not exist. And in our today's, like 4 examples that we went over, all of them are polynomial functions. So we really only just practiced setting the derivative equal to 0. But I'll come back maybe on Thursday where we see a couple of these other cases where the derivative does not exist, and we call them also critical values. But a couple more pictures for you. But this one, if you take a look, I also wrote that the function is decreasing and increasing, to the left and to the right of it. So whenever you have a relative minimum, that's what's going to happen. If you have relative minimum, to the left you will decrease and to the right you will increase. Okay, same thing over here again. You have another relative minimum down here, right? To the left of the graph is going down. And after hitting that lowest point, it's going to go back right up. So relative minimum will always have decreasing to the left and increasing to the right. That's how you tell when you have a relative minimum, because not all critical values are going to be called relative minimum or maximum. But the other way around, if you have relative maximum, that's when the graph goes up to the left and hit that highest point, and it's going to go down. So the picture will look like increasing to the left and decreasing to the right. Same thing over here, right? It's going to go up, hit that highest point, and it's going to go down. So increasing to the left and decreasing to the right. Okay? So that's how you can... Well, first you got to determine the sign of the derivatives. And if the derivatives are positive, then you're going to say the function is increasing. And if the derivative came out to be negative, then you're going to say the function is decreasing. So that's what we did on example video, the video number 2. But just kind of wanted to go over page 2 and 3 with you as a summary. Okay? Alrighty. That was theorem 2, and now we have this big table just kind of talking about how it may be a critical value, because if you take a look right here, the C will have a derivative, assuming this is F, yep. The derivative at C will be 0. The slope of the tangent line at that point will be 0. Well, this one right here, the derivative at C does not exist. Why? Because it's gonna have a vertical tangent. So all of them. What about these two, though? By the way, well, the derivative at that point right there will be 0. So this is where f prime of c equals 0, and this is where another case where we're gonna have a horizontal tangent. So the derivative at that point is also going to be 0. Now, these 4 are all pictures of critical points. These are all critical points, but only the first 2 are going to be considered relative extrema. So take a look. The first one, what do you call this point? C is called relative minimum, because the sign of f of x to the left of this point is negative, right? is going down from left to right. So the derivative is going to have a negative sign. And to the right of it, as you see, to the right of it from C to D, notice how the function is going up. It's increasing. So the derivative will have a positive sign. Notice the sign changed, negative to positive. Let's write this too. Increasing on C to B and decreasing on A to C. So when that changed, we get to call that, and when we have that, we have a negative to the left, or just say decreasing function, decreasing to the left, and positive derivative, which implies the function is increasing. And the picture will look like that, right? Then that point is going to be called relative minimum. Now let's look at the other case, the flipped case. Now what do you call that point? C. We're going to call that relative maximum, right? So if you take a look at the signs here, to the left of C, notice that this function is going up. So the sign of the derivative will be positive. Now let's look at the derivative or the function. It's decreasing, right? It's going down. Therefore, the derivative will have a negative sign. And you see how it changed, right? Positive to negative. If that happens, going up, then hit the point, going down, then that's going to be relative maximum. So let's write it's increasing on A to C, and this is decreasing on C to B. Okay. Now, these two are the cases that you will often see, but just because you have a critical point, it doesn't mean it's going to be a relative extrema. So like right here, take a look at this one for me. Now, to the left of it, A to C. A to C, this is decreasing, right? It's going down from left to right. So the sign of the derivative will be negative. Now, to the right side of C, from C to B, notice it's still going down. It's still going down. So the sign is still negative. Now, if the sign doesn't change, if the sign of the derivative doesn't change, what it did was it just kind of stopped going down for a second, took a little break, and then went down. This is going to be neither relative, max, or min. Okay? We don't call it, that's a critical value, that's a critical point right there, but it's not going to be called an extrema. All right, and we can say this function is decreasing on, it's decreasing everywhere, right, except at C, decreasing on A to C, and start back at C to B. All right, the very last one. At that random looking point, we're going to have a tangent line that is vertical, so we're not going to have a derivative defined there. This is a critical point, but, well, let's take a look at signs to the left of it. Sign to the left of it is positive. The derivative has a positive value because this is going up. To the right side, look at that. It's still going up. That means the derivative will be positive, increasing, increasing. So it didn't change, right? The sign's still positive and positive. So what are you going to say? This point right there, the C is neither relative maximum or minimum. It needs to change, okay? So what can we say about this function? This function is increasing on A to C and C to B. So that's how we kind of tell whether it's a relative minimum or maximum, but it doesn't have to be one of them. It may just be a critical point, and just if the sign of f prime doesn't change, then we have to just say it's neither a relative max or min. And that happened all the way when we did example 6, right? You see how in this example it increased. Let me take a look at this. It increased and increase to the left and right of this point 0. So although this point 0 was a critical value, but this point 0, was not a minimum or maximum. So that may happen, and I think I made sure that that happens on one of your problem. I don't know. I can't remember. But anyways, you've seen it all. You've seen it all. 3.1 was a little bit longer, but you got everything. after watching these 3 videos. I'll be back with more fun stuff on Thursday, the 3.2. But I look forward to grading your 3.1 problems, and please get started on your My Math Lab homework too, okay? Alrighty, talk to you later.